Before you get started with the homework on section 2.7, you should review my video about the transformations. Once you get the hang of those transformations, you can actually identify the graphs of these basic functions that have been transformed fairly quickly. For the first one, without using a calculator, we want to choose the graph that matches the function y equals the quantity x plus 2 squared plus 4. Now this graph is a graph of the basic function y is equal to x squared. And review the last section to in terms of how you graph the function y is equal to x squared. You can make a table of values, but that's our basic function here. Y is equal to x squared. The transformations that have been done here include adding a 2 in parentheses. And what that does, the x plus 2 in the parentheses, actually makes this entire graph shift over 2 units. So our new graph would look like a parabola. Instead of the vertex being right here at the origin, it's going to be shifted, to the left 2 units. If it's a plus 2, it gets shifted to the left 2 units. If it's a minus 2, it actually gets shifted to the right 2 units. And this graph would be a parabola that opens up, just like the previous one that's been shifted over 2 units to the left. And then another transformation that has occurred is after it's been shifted to the left 2 units, we have this plus 4, which means we're going to take this whole graph and move it up 4 units. So it's a graph of a parabola that's been shifted to the left 2 and up 1, 2, 3, 4 units, and then you get your parabola that opens up like this. This is a quick sketch of taking this basic one, shifting it over 2 and up 4, and then your resulting graph. Without using a calculator, I can identify that this graph matches C. Let's look at number 2. To graph the function using transformations, we have our function g of x, which is equal to -2 absolute value of x. Now the basic function, we can say y is equal to the absolute value of x, is the function that is a basic absolute value graph. It looks like the V graph. Now when you transform this by multiplying this by a -2, this negative would indicate that the graph is no longer going to open up, it's going to open down. And then that -2 actually makes it more narrow. You can plot a couple points if you want to, and the graph is going to be opening down, and it's going to be more narrow. So that's what your graph should look like. You can always make a table of values for the new graph. Just a couple points should do. If you plug in -1, the absolute value of -1 is 1 times a -2. 1, -2 is a point that's on the graph. If you plug in 0, you get 0. You plug in +1, absolute value of +1 times a -2 is a -2. So this graph has the points -1, -2, that's a point, 0, 0, and +1, -2. You can compare with the choices given. The one that looks most like this is C. Our basic absolute value of x graph is in blue and the new graph is in pink. Select C and check our answer. Let's look at number 3. Graph the function using transformations. And our basic absolute value of x graph looks like the V graph. And you can go back to the previous section to look at how I sketched this. And then that negative in front, hold on, the g of x has a negative 1/3 absolute value of x. Now what that negative does, it's going to make it open down, and that 1/3 actually makes it wider. It's going to be a wide absolute value graph that opens down. You can always choose a few values for x and g of x. For example, when x is, I'm going to choose a big enough number so that I can get a nice point. For example, -3. When x is -3, the absolute value of -3 is +3 times a -1/3 is a -1. If you plug in 0, you get 0. If you plug in +3, you get -1. So the points that are on this new transformed graph are the points -3, -1, negative, +3, -1, and of course 0, 0. And you can see that it's an absolute value graph that's been flipped down because it has a negative coefficient, and it is wider because there's a fraction. And that looks most like B, but it kind of looks like A. I just want to check. No, A has actually been shifted down. So A would not be the correct choice here. We're going to choose B. Let's look at number 4. Graph the following function. Now this is our basic function which has been transformed. If you take the basic function y is equal to x squared, you have the parabola that opens up. This new function here is y equals x squared minus 1. That minus 1 on the outside results in a shift down. Again, review that video. So this whole graph has been shifted down 1. So it is a parabola that opens up. It has been shifted down 1. And you can always make a table of values if you forget, but you should really try to plot enough points so you have a good idea of what the shape of this graph looks like. So if we plug in, say, -1, squared is 1, you get 0. Plug in 0, you get -1. Plug in 1, you get 0. These are points that are on this transformed graph. -1, 0, -1, 0, 0, -1, and 1, 0. If that's, we can check the choices. It looks like choice B is the parabola that's been shifted down 1 unit. Looking at number 5, here's another one. We want to graph this function, which is our basic function y equals x squared, but it's been transformed with a -5 on the inside of the parentheses. So our basic y equals x squared graph is a parabola that opens up. Okay, and then what happens with this new graph? It's been transformed, the x minus 5 quantity squared. This -5 means that this entire graph has been shifted to the right 5 units. So this point on the original, if we move it over 1, 2, 3, 4, 5, that's a point, new point on the graph. And our graph is a parabola that opens up that touches right there at +5 on the x-axis. If you are going to make a table of values here, be careful because you want to choose enough points so that you get a decent idea of what the graph looks like. So if you make a table x and y, which is equal to x minus 5 squared, if you try to just start off with a 0, for x, and you simplify, you get 25, which is going to be off the page. So you want to try to choose enough points kind of around this vertex of the parabola. So I'm going to choose perhaps 4, 5, and 6 as x values to plug into this function. If you plug 4 into the x here, you get -1. -1 squared is a +1. If you plug in 5, 5 minus 5 is 0, squared is 0. And plug in 6, 6 minus 1 is 5. I'm sorry, 6 minus 5 is 1, and 1 squared is 1. So these points, over 4 up 1, that's over 5, 0, over 6 up 1. Those are 3 points that are on the parabola. Check. Out of all the choices, this one looks most like A. It's the basic parabola. It's been shifted to the right 5 units. So again, the key to doing these types of problems quickly without having to use a calculator or a table of values all the time is to understand. So the best way to do these is to know your basic functions and to understand how just these little changes will transform the graph. Memorize your basic functions and understand how to transform them, and these questions you should be able to do very quickly.